Okay, so today we'll be doing an intro to Linux. And then this penguin right here is like the Linux mascot. So yeah, we'll be talking about Linux. Okay, so what is Linux? So Linux itself is the core of many open source operating systems that differs from other operating systems like Windows and Mac OS because of its flexibility, security, and stability, and most prominently the use of the command line. In contrast to GUI, which is your graphical user interface. So rather than like working a lot with like clicking stuff, you're going to be typing a lot for most of the part, which is the use of the command line. Some popular Linux-based operating systems include Ubuntu, Debian, Arch, and Kali. So the Kali that you guys installed on your VMs is a Linux-based operating system. So what I'm trying to get across here is that Linux is not just one operating system. It's like the core of many operating systems. So yeah. So it's less common amongst casual users like you and me, right? Because it's more widespread. Than, Windows and macOS is more widespread amongst casual users. Linux is more prominent in things like web servers, embedded systems, IoT devices, and development environments most commonly feature Linux. So yeah, Linux is way more prominent in these kind of devices. And the thing is, you might not think this, but Linux is actually used in like over 1 billion devices worldwide. And this is because like, in contrast to like casual users like you and me, Linux is like used all the time in like development environments. So it's not just one person that's using, or one person can have multiple computers, right? And multiple systems. And especially companies will have multiple, even like thousands of operating systems, Linux operating systems in use in their environment.
Yeah, and to like put things into like perspective, every single Android phone you see is running Linux. A lot of like cars, like if they have like a little like interface you can mess around with, it's probably running Linux. If you see like kiosks like at a store, every single not every single one, but like I'd say like probably 90% of like if you're like going online, like the Google, Facebook, whatever, any like web server that's being hosted online, it's probably running Linux too. So that's why there's like billions of devices or servers running Linux. So it's like really important to know Linux.
Sorry. Okay, so why do I need to learn Linux? So the command line in Linux has a number of features that allows us to be more powerful than GUI. So rather than just like clicking stuff, you have more power because you can be really specific about what you want to do. So first things first, you can accomplish automation and scripting. So yeah, scripting allows for automation. You don't have to manually do things one by one. You can do it. You can do like a repetitive task really quickly. You have fine-grained control. So like I said, rather than just having a limited number of options like you do in a GUI, you can specify exactly what you want and you know exactly what you're doing, rather than being like, oh, this button says I'm going to log in. Well, am I actually logging in? What if it's doing more in the background compared to just logging in? So efficiency and speed, right? So the command line uses less resources because it doesn't use all the resources to like literally come up with a GUI and like present it to you. Tool usage is really quick because once you're familiar with the command line, because you just type stuff rather than like having to take the time to click stuff. So it can be really efficient if you know what you're doing. And there's also extensive tooling and flexibility. Tools can be combined, modified, and compounded. So you have like one tool, but what if you want to use the output of one tool and then combine it with another tool, right? You can utilize the command line and take it to your advantage and do things like that. Okay, so first things first, right? Like, so what is a terminal? So a terminal is a text-based interface that interacts with the operating system. So it's like the middleman between yourself and the operating system. So that's why the terminal is basically direct communication when issuing commands and executing programs with text commands. So whenever you're typing things, you're directly interacting with the operating system. Within a terminal, you can do a number of things, right? You can navigate the file system. So in Windows, you have the file explorer, right? But you can actually explore the file system with the command line too. You might have played around with it, but you can do that with command prompt in Windows. You can do that with Windows PowerShell. Those are all like terminals. So yeah, you can also run programs. You can manage files and directories, and you can administer configurations. You can do a lot of things with within the command line and also the application of a terminal. These are popular applications popular terminal applications that you maybe have used before, and if you haven't, then you'll learn about how to use one today.
Yeah, and it might be like hard to believe at first that you can like do a lot with terminal. Most people like really used to like a GUI and like using your mouse, moving around, clicking things. But believe it or not, you can probably do like 90% of the tasks you do on a GUI on the terminal. People have even went and like made like Spotify accessible through terminal, and like you can navigate songs and stuff like that. The only thing I'd probably say you couldn't do in a terminal is like a web browser. But besides that, you can almost do anything with a terminal, so it's really powerful.
Okay, so I don't know if you guys have used it before, but if you log into, or if you know about the Fullerton College Computer Science server, when you're like SSHing in, you're just remoting in to the Fullerton College server, which is running Debian Linux. And so this is like a command line prompt, and the tool you're using to probably communicate with the server is a terminal. So pretty cool. Okay, so let's talk about the Linux file structure. So within Linux, everything is a file, and even directories. So you might think like, no, it's a folder. Well, it's actually called a directory, and technically they are still files, but obviously with directories, you can group files into them, which is kind of a weird concept, but that's how it works. So we'll be talking about these 7 different directories that exist, just to give you more of an idea. So the top directory that you see right there, the slash, is called the root directory. So it basically just is like the top of the hierarchy, right? Because the Linux file structure, just like Windows, is like a hierarchical structure. And so your root is at the top, and then you have subfolders and subfolders and subfolders or subfiles. So the first directory we'll be talking about is /bin. So this is where most of your binaries go, and binaries are basically just executables, right? These are basically the programs that you're running when you do things, when you run commands in your command line. So you'll learn about commands, like common commands, but there are things like ls. When you run them, you're basically just referring to this path and running the executable.
And ls is a command on Linux, by the way. Yeah.
So that is a command, and it exists as a binary in this folder. So most of your essential binaries will exist in this directory. And then we have /etc. So /etc stores system-wide configuration files, contains various settings and config files used by programs and services. We'll talk about services, but yeah, this basically contains a lot of configurations that you want, or that are specific to certain programs and certain services. So pretty important.
So after the /bin and /etc, that's where you usually keep your binaries and your configuration files for the programs that you have installed on your Linux system. For /home, it is where all the users live. So if you would look at our FCCSDI system that we have in Fullerton College, they would have a /home, and in there they have different directories for each and every one of us who have enrolled in a CSCI course. So all of your users, their personal configuration data, their personal files, all of them go into /home. So the way that all of this works is like Linux, when you install it, like if you would install a Windows system, you would see that you see a C disk, D disk, and then in there you have users, downloads, documents, and everything. So it's a little organized. The way that Linux does it is this organization, where in home, it's similar to your users directory on Windows, where you can keep all of your users and they keep all of their files over there. For /opt, it's actually a little interesting because it keeps all like the additional software packages. The way that I might phrase it is, it could be, it is the things that you install that are not part of the system distro. So if you would install additional softwares, that's where the software packages are kept.
Yeah, and like so /bin is like basically everything that's like pre-installed with the Linux distribution will be in there, and then anything else that you add on, maybe you find something on GitHub as a binary, you stick in /opt.
/tmp is the same as temp that you would find on Windows. It's just where Linux keep all of its temporary files. Let's say you opened a program, but how many of you know that what happens once you open a program? what does it do? Or maybe when you open a file, how does it open a file? Like, what does it mean for a program to open a file? Or maybe modify it. So here's how a really high level overview of it looks like. Whenever we open things, what it does is it needs to keep its temporary data somewhere, and it keeps that in terms of files. So it could be random data that you cannot read, or you can actually read it, but you wouldn't understand at all. That's where it keeps your Linux programs keep their temporary files, and it's always, most of the times it's like a refresh on every single reboot. So whenever we reboot, this directory gets flushed and then you get allocated the thing. For /usr, it's about the files and directories that are related to user applications. So whenever we do apt install Vim, apt install some other software. So in the USR, it actually keeps all those binaries and libraries, the DLLs, and the installed software that you install. So USR is for the things that you install, usually using apt or DNF, whatever your package manager is. For TMP, it's the temporary ones.
And we'll talk about package managers later on too.
Yeah, he said like APT, that's like a package manager tool. So we'll be talking about that too.
This is like the store version, the CLI version of Microsoft Store or Apple Store.
Okay, so /var, short for variable. So this just contains files that are like prone to changes, such as websites, like temporary files, logs, databases, etc. That's all it really is. Do you know anything more about that?
It's just that once you have for /var, it's let's say you have installed a web server and you want to keep your website that you will change every now and then. So all of those files which are subject to change, you keep it in the variable directory. That's pretty much.
Okay, so basic Linux commands. So at a very basic level, Linux commands are comprised of three things. So we have the command itself, the thing that's like the basic command, right? So for example, we're going to use ls as an example, right? So we have the command ls, and then we have multiple options. So we put -lah here, but what we're doing is we're combining three options. It's -l, -a, -h, but we're just using that as an example. And then we have arguments. And for example, we're providing this piece of data called sscb.txt. So the command itself is a binary in the Linux system we talked about, right? In /bin on the Linux system that you can run to execute a certain task. So ls will do something. And just to like talk about it here, we're going to talk about it later too. But what ls is doing, it's listing the directories, whichever directory you're in, or that you're referring to. But yeah, it's short for list. So that's what it executes. That's the task it performs. And then we also have options, and these are part of the command that enable functionality. Yeah, so options are part of the command that enable functionality. So we have the base command, right? But what if we want to do something more specific, right? Or what if we want to do something more? That's when we can specify options that tell it, oh, we want to do exactly this, plus this, which is why we have three options. And then we have arguments. Basically, arguments most of the time are information or data that you provide for the command. So we want to list, we want to do list, right, which is ls. But we're also specifying this piece of data, which is a text file. So that's what we're providing to it. So just again, the first part, ls, is the command itself. The law are multiple argument options used, and the sscb.txt is the argument. Yeah.
How many of you have used ls with the -l or a or h flag in the past? So it was just ls to list the directories?
Yeah.
What does the L do? Yes. So what it does is for list, but as Sohi was mentioning, the -l, a, and h, these are just parameters to actually help you make the data look more feasible or whatever the command provides you. So if you want to just not look at the files and folders in a raw format, you want to see it in a column format, that's where you use the -l. And A and H provide similar functionalities, which will be covered afterwards.
Okay, so you're probably wondering, like, we have ls like log, right? Well, what the heck is log like, or how do I know what it's gonna do? So really important thing to know about is the man binary. So there's a binary on Linux called man, which stands for manual. So you can stick it in front of basically any pre-installed binary stuff in /bin on a Linux system to see the manual for the command, which will tell you what the command does and options you can use with it. So like, for example, we have man ls, right? It tells you ls stands for list, and then also like list directory contents. And then it tells you the like syntax, right, that it wants. So ls and then option file. So like the basic like template that you should follow when you're using this command. We have like more of a description, and we have all the options that are available that we can use for the command ls. And like I said, you can do this for like basically any pre-installed binary. So if you're like wondering what a specific command does or what it can possibly do, you can use the man page.
Yeah, like we mentioned like before, like ls-lah, like the L was like the long listing format, but like even I didn't really know at first, like, oh, what's the A in it? You can see right there on the picture. A, it says do not ignore entries start with dot. So any files that start with a dot, if you didn't put a -a with ls, you would never see it. But if you do -la, you get a long listing format and you'd see files that start with a dot. So maybe you want to see those, maybe you don't. You can add on flags, whatever you want to it, and a manual can help you with that.
The one thing for like most of us Linux users, there's like a lot of commands which you will never remember them all, and there's like hundreds of flags that you'll never remember. So it's just really efficient to get yourself used to how to use the man binary. But at the same time, nowadays in the modern Linux distributions, and you would see that in Kali as well, you have the info binary, the info pages. What it does is it tries to like simplify the man page in a bit, and it provides like much more of an easier outlook on the tool. But man is something that you would find on pretty much every Linux system that you are at, and whenever you are stuck, you just have to search and you don't have internet, just use man space the command name, and you have enough information to solve whatever problem you have at that point.
Okay, so we're gonna do like a little bit hands-on because for like in my opinion, it's more useful to like actually do something rather than just like learn about it here. So if you can like if you have a terminal or if you can like open up your Kali and open the terminal. Yeah.
What is 0.0?
Oh, it's like a face. You see it? It's like eyeballs and then like dot. That's all it is. So yeah, if you want to like open up your Kali and then you can open up the terminal there. Yeah, if you need help, you guys can ask us.
What if you put like parentheses? So those like
Emoji add, you can like.
no, I did.
I just do that all the time.
Kause, CO.
Oh, I'll say, oh yeah.
Yeah.
Do you wanna show?
You can show them. But I'll show you what happened.
Just click on the start and then just start. Yeah.
Did I have it open?
Yeah. Start. Hey, let's show you. Oh man, let's go with me as well. Make it like. Yeah.
Oh,
Right, very delicious.
That's I do like. Oh, no, dude, it's not gonna hurt anyone. No, we're talking about tomorrow.
If somebody is having any problem on the Zoom chat, they can ask on Zoom chat.
That's what he does. That's insane. I say push the legs.
Listen, nice. So if somebody is, we are gonna be doing a live demo, and if somebody is having a problem with their Linux Kali having problems while opening, feel free to drop them on the meeting chat, or if you would like, we can send you on the breakout room and you can we can assist you over there as well.
Yeah, no. Oh, yeah.
No, that's like.
I think you were the one who configured.
Did you make
Did I?
it? Yeah, you made it for him. He has Kali.
There's no way, wait.
You didn't say for that.
Tony.
Wait. No, I sort of once, I didn't put me like, wait, hold on, listen, dude.
What was the name of the VM?
Okay, if I did it, it was something bad, that's all.
Name that. What else were you expecting?
Oh, wait,
Do you remember when you?
wait, okay, what is the name though?
I remember the VM name, you did it in front of me, but not the password.
Like, it was like.
If you have one, you just like.
Oh, my gosh. What was the name of it? It was like.
Oh,
Oh, no, are you sure?
Yeah.
No, wait, no, that was, wait, no, because I asked you, okay, that's it, no, I don't think it's that though, because I asked you like something, oh. When do you see the name of this thing, and you say you don't see it unless. you
yeah, that was the main name.
No, wait, I don't think it's that. Don't tell me, okay, no, it's not that, it's not.
Yeah. Here's the thing, rather than trying to reinstall the thing, you can just wait and, yeah, just load it on the live source. So you don't have to install it, just do it on the.
Look at some. I don't think.
Or you can do it on hard drive. You can either the same thing.
No, I'm not. It's different kinds of numbers.
That's what a friend does, right?
Yeah, exactly.
Right, you understand, see, you didn't even see what it was, but like, you just know.
I can imagine it's.
Okay, if you can't log in right now, you can just look at someone else's, but we're just gonna go over like some basic commands, so it's okay if you can't do it right now.
You named it yourself, because I remember, I named like the name of the thing, whatever the fuck.
Okay, so we're gonna go over some basic commands, so you guys can like try all this out, but I'll go in order. So like I said, ls is just listing your directory contents. You guys can look at the man page whenever you want, but ls by itself will just list your directory contents. So you're probably, if you open up your terminal right now, you're in your home directory. Oh, okay, you'll be in your home directory. So if you list the contents, there might be something depending on if you created a file or not. But yeah, if you want to create a file, we didn't put it up here, but I guess you can use the touch command. So you can do a touch and then file name, a space file name, and you'll create a file. And then after that, yeah.
Do you need quotation marks?
No, you don't. No, you don't. Unless you're doing some weird name, but like with characters. But usually if you just do like alphabetical one, that'll be fine. So after you create a file with touch space file name, you could do ls and you could probably see your file.
Oh,
You can, yeah.
What?
Yeah.
I did one.
I think for these commands, you can also do it on your Mac terminal if you guys have a Mac.
But Windows,
Those PowerShell.
unless you have Windows.
Yeah, that's-
You want to show your terminal and like walk through it too? Hey, show me.
Pro hacker now. I can add. it to
Delete a
the
directory or something.
but
Where is it? So confused.
It's touch, base.
Touch and then whatever the name.
Right, but that's a great file, right?
Yeah, and then go.
Okay, let me
look at it.
turn this off.
Oh, no.
Okay. Okay, so I'm in a directory right now. I'm not in my home directory, but I'm just in a general. What are you doing?
Make it bigger.
Oh, that's true. I'm just in a general directory. So the first thing I'm gonna do, just like show you guys, is just run ls. So right now I have nothing in here, right? But let's try using like the options that we used using the example. So ls log. So you can see here we have like the dot files. You don't really have to worry about this, but the single period represents your current directory, and the two periods together represent your previous directory. So yeah.
Well, our directory is kind of like. Their own users.
They're like folders on Windows.
Yeah, they're like folders.
Yeah. So you can think of it as like a folder, like when you have like if you have like your documents folder, and then you made a new folder called like homework, you'd be like in documents, homework, and be files in there. So it's like a directory called documents, and then within the documents directory is a folder called homework, and then within that is another one.
So the current one we're in is the home direct.
Yeah, I mean,
Your home directory.
let me see. Where.
I mean, I switched it to my Superman. directory.
Yeah, so you're in some directory. It's not directory, but it's like folders.
Okay.
Same thing. Yeah.
Oh,
Yeah.
So I'll just go ahead and like create a file. So if you haven't done this already, you can use the touch command and we can name it whatever. So file.txt. And so if we run ls now, you can see that we have file.txt because it lists your directory contents. So pretty cool. So we can move on to CD, which stands for change directory. So you can move back and forth between your directories. So like I said, the two dots, this does, references your previous directory. So you can use the CD command to go backwards, to basically go up a directory. So what I'll do is ... And if I press enter, I can see that I'm in my previous directory, which was code. And if I want to go back, I can list it. Oh, I can see that I have FCCB and now I'm in a directory. So that's a CD command. You just move back and forth mostly with CD.
Oh, also, it's like it's not on the basic commands, but if you run pwd, that stands for parent working directory, I believe, or present.
Oh.
Whatever, I always forget. Anyways, it'll print out where you currently are, basically. So if you hit enter, that's the whole entire like path. Path basically means like exactly where you are on the directory. So he's in users, so he code FCCB, and if you do CD change directory ... so go back or go up a directory and then run pwd again, you'll see it went up one. So now we're in users, so he code. So we basically went up one. And if you go CD to FCCB again, it'll just go down a directory.
So we'll change directories back into FCCB and we see that we're back into FCCB. Now we can try making a directory. So like I said, what I did right here was I created the FCCB directory in code. So how I did that is I used the make directory command, mcdir, and I just name it whatever I want. So I can name it like example directory. And I press enter. And if I ls, you can see that, well, it's notated differently here because my color scheme, but yeah, you can see that we have the example directory. And you're probably wondering, if I don't have like colors or whatever, how can I see that something is a directory versus a normal file? And if you run lslaw, it kind of gives you a more detailed output of your directory contents. So you can see here that for the example dir, like this line right here, it has a D compared to this one, which has slash. So when it has a D here, it's referencing that it's a directory compared to just a normal file. We'll be talking about like what the DR, WX, blah, blah, blah stands for when we get down to permissions, because that's what it is. It's referring to permissions, but that's how you tell the difference between a directory and a file. We can also remove files and directories. So if I ls again, also you can run clear to clear your terminal, but sometimes it gets messy. But I can run ls again. And what if I want to remove file.txt, right? Because I don't want it anymore. Then I can just run rm, which stands for remove, and I can just do remove file.txt. And if I ls again, it's gone. Just know that if you run rm, it's probably going to be like gone forever. So just be careful.
what did you do to make it gone from?
Oh, rm.
Oh, RM.
And then you can also remove directories. So there are two kind of like different ways between removing directories. So you can do remove rmdir, which is not actually that common. People don't use this that often, but you can do it this way. You can do remove directory and then the name of the directory. By the way, you can press tab usually to like autocomplete. But you can press enter, and if I ls again, you can see that it's gone. But another way of doing it is if I make another directory again, and I lost, it's there. You can also do rmrs, which is like basically, or you could do, I think just R2, right?
Yeah, the -R option is like you're recursively deleting something.
Yeah, so
As in like you're just going in over and over and over again, deleting something.
yeah, because if you had content in example directory, so I'm seeding into it, and I can make files in here, right? I can do like touch file 1, touch file 2. Now there's like stuff in here, right? And if you use RMDIR, or if you use RMDIR with your example directory, it won't let you do it because it's not empty, because it doesn't want to just like throw away stuff that maybe you don't want to delete. So it won't let you do that. But with RM, it's a little more, well, you can do more of it. So you can tell it to remove recursively this example directory, and it'll do that for you, and now it's gone. So yeah, you can use that. That's what I use more often. Yeah.
So what is -RF?
Oh, so -RF.
Yeah.
So I'm pretty sure the F is like force. So sometimes there are like files that don't want to be deleted. So if you just did -R, it'll be like, oh, warning, like this is a file that like should not be deleted. But if you do force, then it'll like automatically delete it, just force.
So if you were to do like /,
Oh,
then it'll like wipe out the whole directory and it wouldn't let you do it. But like, let's say if it's a file that's opened by another program and you are trying to delete it. So last it's already open a file in progress or something, but if you use F, then it's like force deleted, no matter whether it's open in another program or not.
Wouldn't it crash? Wouldn't it crash?
it could, yeah.
Yeah, it will.
Yeah.
The program.
The thing about like Linux compared to like Mac and Windows is Mac and Windows have a lot of like safeguards or like safety rails kind of,
Yeah.
where they won't let you delete certain things. But for Linux, it's like, oh, you did RF, run it, let's go. And that's a good thing maybe, because like you're a developer and want to do something like that's like, you just want to do your own thing. Like you have full control over Linux, which is like why a lot of like enthusiasts love it so much compared to Windows, where it's like, oh, I can't do this, I can't do that. Linux will just be like, do whatever you want,
So couldn't you delete
everything.
The system, yeah,
Yeah,
you
so
could.
there's like, yeah, there's like a meme where it's like, oh, like you do RM-RF and then / that's the very top, and you can do an asterisk for basically it's a wildcard. I can talk about that too a little bit. Basically, it's like RM-RF and then just delete absolutely everything going down, and it'll just start running it.
Because slash is top, right? So
Yeah,
everything
yeah,
under
let's
it,
go
you're
down.
deleting everything under it.
The whole system is now gone. Now you are left with nothing.
Yeah, and it's like the, oh, everything's okay and meme with fire everywhere. Yeah,
So yeah, that's something you can do with RM. You can also copy files. So let's say you have let's touch another file. So let's say you have a file and you want to create a copy of it. So what you usually do, the basic syntax is file.txt, so the source file, right? And then you also reference in your second parameter the file you want to copy to, and this file doesn't have to exist before you make it. So if you see right now, I only have file.txt, but if you want to copy file.txt to file2.txt, it doesn't exist yet, but now it does because I copied it. So they'll both contain the same thing. With move, so move itself, like you're moving files, right, or moving directories. But you can also rename stuff with it because it's essentially that's what it's doing. So if I have I'll just make a directory. So if I say I want to move file.txt to example directory, right? I can easily do that. I can do file.txt, which is my source, and I can move it into this example directory. And so if I look here, file.txt is gone. But if I look in example directory and ILS, you can see that's here. But the thing is, what if I have file.txt, but I want it to be named file3.txt? So you can also do that with move, interestingly. You don't have to have like a rename binary. So you can do move file.txt, and you could call it file3.txt. And basically your source is your file.txt, and your destination is file3.txt. So you press enter, and basically it'll just move the file to a new file called file3.txt while getting rid of file.txt. So it's pretty cool. You don't need like a whole rename binary. We also use cat often, which is basically a binary to display file content. So I'm just going to use a text editor real quick because it's easier, and we'll talk about text editors after. But basically I'm just going to be editing the file. So I'm just going to put like hello world, and I'm going to save it. And if I want to see what's in this file, I can use the cat command, so file or cat, and I can do file3.txt, and I can see that it printed the contents of the file, which is hello world. So that's what you can do with cat. You can also use find.
You're gonna scroll it.
Oh, grep, sorry. Oh, you can also use grep. So grep is pretty cool because usually you'll use it in combination with a different tool. So if I click. So say I had like, okay, in this directory right here, I don't have too many files, right? And I can easily see what's happening. Actually, let's go back here. I don't really care if I show this. So I have a lot of files in this previous directory, right? And there's so many files. I want to look for something specific. So what you can do is you can actually do ls, but you can actually combine it. I will talk about this too. We'll talk about this operator that we're using, but you can combine it with this operator called the pipe operator, and you can use grep, and you can search for a specific text pattern. So let's say I want to look for scripts. So then I can type in scripts, and it'll tell me, well, it'll show me scripts, and I can also do like ls loss grep scripts, and it'll tell me information about scripts only. So it'll like isolate that line.
Yeah, and you can even do like, it's like when she ran ls and you see like, if you just look at her files, you see like multiple Python files .py. You can use grep and you can do ls type grep and then .py, and you can do that too. It only show like the Python files because the one he did only shows one thing, but you can show you can run multiple.
What if you
Yeah.
did like ls grep s?
Just S, and it'll just it'll
Find everything with an S in
with
it.
the S in it, yeah. So you know how it's like highlighted red.
Yeah.
So my name is Sohi, so it just shows a bunch. But if you did like what Bryce is talking about, like .py, it'll here, let me clear it clear. But if you did .py, it'll show you all the Python files or anything that has py in it.
This thing over here for grep, what it uses is regular expressions. So when you see that she searched for .py, but you see that there's something as _py as well. So in your developer journey or in your like Linux journey, you would study regular expression. It's like a whole new study of how to build text patterns. And that's how your validators work. Like you would see on a website online when you write your email, it asks you to add the the @ and .com or .something. So this is what it follows. So you can do a lot more fun stuff with grep as well. And it's like a really handy tool to have at that point.
But yeah, we're not going to go over regular expressions because you can take like hours trying to go over it, and it's extremely convoluted and annoying. So yeah, if you want to learn about it, you can definitely, and actually it will be really helpful if you do learn it, but it's not necessary whatsoever for like the bootcamp or anything. It's just a convenience type of thing.
So do you know something for find? I barely use find.
So for find, what you do is, let's say, so the way that find is used is if you want to search for the same patterns, but for files and folders. So let me show you an example. What was FCCB?
Yeah.
So the way that you would use find is, let's say you had another directory as maybe tester directory. Okay, so you have multiple directories over here, and you could see like in the above directory, you would see that there is a lot of directories and files. So in order to find files and stuff, you can also do ls-l or like pipe it and use grep to find something. But what if it was something like it's in sohi /something/something/something. Let's say if you wanted to find an example directory, you had another directory called Nasser. And if we go back, you have, so now if I want to see that in this FCCB directory, do I have a directory as Nasser either in the subdirectories, in the top level or anywhere? So that's where you use find, and -i means that it's going to be case insensitive. So it would look for capital NAME or capital smaller n, and then you write iname, that's like providing the pattern or what's the name that you're looking for. And Nasser dot, I always mess this up, so it could either be dot and Nasser or it would be this. Exactly. So find Is this Mac?
Hmm?
Are we on the Mac terminal?
Oh, no, we're in this. Go back to it.
In your Linux terminal, this would work fine because the BSG in the Mac, there is this binary, but it has different flags. So if you would try the same thing on your Linux machine, it would actually work. So you can create a folder, and in that folder, you create another directory. And in there, when you would do find-i name space the name of the directory and dot, or it's dot space the name of the directory, it would work. For BSG, it's a little different. As you would see that the find command over here is coming from BSG. Yes.
The
Yes.
reason why I'm saying it's different is because different operating systems might have different binaries. So this binary of find on my Mac OS computer doesn't have the same binaries as the one that you guys do on your Linux machines.
Yes. So did anyone try it on Linux?
Yeah, it would.
Yeah,
It worked?
but-
So it is find-i name, whatever the name of the folder is, and then it's dot, right?
I didn't put it on.
Oh, it assumed to be in that directory?
Oh, yeah, so what the dot is referring to, it's referring to the current directory. So you can also refer to like different path locations, but when it says dot, it's referring to your current directory. So that's where it's searching.
Yes, so the find binary is very helpful when you want to like look for files and folders which are in like subdirectories, because there's no way you would get into every directory and do ls and grab it. So find does that all for you. You just have to give it the thing that you're looking for and it'll do it throughout the Linux system.
And then lastly, we have history for the basic commands. So history is just really really helpful and like convenient because it like just logs what the past commands that you've issued on your user. So for example, history is kind of like why you can like press the up arrow on your computer and you can go to your previous commands. It's because it keeps track of what you've issued, but it can also be taken advantage of because when we're talking about like red teaming like and stuff like that, history can be really useful because what if you logged in as a user, right? That isn't your user, you hacked into it. And you want to see maybe it's like a developer, right? What have they been doing on their computer, right? You can just type history, and if they don't clear their history, or if they don't like sanitize or whatever, you can see exactly what they've been doing. And sometimes they might like accidentally like, you know, when you're doing Control-C, Control-V, right? You might actually Control-V your password into your terminal, and sometimes just press enter, like, oh, whatever, I don't care. But that might actually be like seen in your history. So you can always take advantage of that, but most commonly it's just used to look at your past commands. If you like forgot a command or you want to see what you did before.
Yes.
How do you clear history though?
Oh, you clear history? So it depends on your shell.
Yeah, so actually, if you go into your home directory where you are and do ls-leh, you might see a --_ history.
Oh gosh.
I do.
Let's see. Oh,
A
dude,
little correction on find. The command is actually let's see.
Oh wait, it's in here. Let me change it.
Oh,
It's different.
Because, yeah, we'll talk about that a little later, but, yeah, so if you actually. Nice.
So it's going to be find, and the directory that you want to look for, are you trying to look for in the downloads directory only? Do you want to search for the whole system? So you tell that, and then you write in sensitive name. Should be Nasser. Let's see if yes. So it actually worked. It was my mistake. I put the dot after it. You first had the way that this command works. If you would open the man page, it takes the find command, then the directory that you're looking into, and then what you want to look for. So I'm saying look for all the things which have the name Nasser. And where do I want to look for it? In the current directory. So it says that there is a directory or there is a file in the example directory with the name Nasser. So that's how find actually works.
Okay.
Sorry, how do you clear your history?
You find it on.
Oh,
Yeah,
yeah.
thank you.
Yeah, you can do that, or if you do ls-leh. Oh yeah. Yeah. And you'll see this like .zsh. I'm sorry, so you have to cut that.
Is that on my machine?
and-
Probably is. Where is my mouse? I can't find it. Oh, I found it. Let me see if I have it on my machine.
WSL?
I don't have it.
Oh, you have it.
Oh, that's great. Maybe I shouldn't show this.
And you're to close your national.
Wait, did you get it? I thought you got it. I thought you got it. You didn't log in? Oh, I thought you logged in.
You have to reinstall the thing that.
So just like what she was talking about. So if you want to clear your history, right? So you go to your home directory, and I'm in my home directory. It's a little different on Mac. It's /users, but it's the same thing as /home/ your username. So I'm just gonna it's reach under right. So I have this file right here. I'm not gonna look in it because it's my history. But yeah, it has all my previous commands. So if I do like ls, this will be stored in my CSH history. So by the way, CSH is like a shell, yeah, your current shell that you're using. Not a big deal, but depends on what your shell you're using. But on Kali, it's also CSH, so it should be CSH_history. But the way you can delete that is just literally removing that file. Just delete that file. But that just goes to show how everything is basically stored in files on Linux, right? That's literally how your history is stored. You can see it in a CSH_history file. So pretty cool.
Just a thing to add, like most of you, when you are writing something, you would see that it auto completes it. That's where it's reading it from. So any command that you would write, it gets recorded in history, and anytime you write something similar to it, it reads it from that file and shows you that auto completion thing. So that's where like the history comes into play. For the most part, don't delete it and keep it.
Okay, so we're gonna move on from basic commands and we're gonna go to less basic commands. So this is just like the reason why we're showing this is because you probably have to use it for your homework and the lab that we do after. But we have SSH, PS, challenge, sudo, netstat, diff, curl, get. So okay, so let's start with SSH. So you're gonna have to use this for the first part, for the first level of your lab today. But what you're gonna do is you're gonna just type in SSH, and usually you don't have to specify your port, but you're gonna do -p to specify your port. Should I talk about this right now? Actually, we'll talk about this later. I have like a slide that like shows you how to do it, but I'll post the slides so you don't have to worry about memorizing the commands, but we'll talk about this after since I feel like it'll just be more confusing if I talk about it now. Yeah, this is fine. Okay, text editors. Okay, so text editors. So you guys saw that I used a text editor called Vim when I was changing the contents of a file. So basically a text editor is a software tool designed for creating, editing, and manipulating plain text files. Did you get it?
Yeah.
Okay. So that's what a text editor. Okay, so Linux systems typically come pre-installed with some text editors such as V, Vim, Nano, Emacs, etc. So these are like your 4 basic text editors that I usually have. So we don't have to talk about all of them, but usually people use Nano or Vim. Vim is like a little more it's less beginner friendly because it's a little more fast paced for advanced users. So for most part, you're gonna be using Nano, just like get comfortable with a text editor, because usually you guys like use something like VS Code, right? Where you can like click around and edit your text or whatever. But with things like Vim and Nano, which are text-based editors, or text editors, you can't always like click around like that. You're gonna have to move around with like your arrow keys or something, or like a keybind or whatever. So yeah.
For the people who have taken any CSCI courses over here, you guys have worked. What was your editor that you used over there?
Micro, maybe? Micro?
Micro? Not supremacy, but Micro and Nano are like the ones that you start with. So does Kali have Micro already installed?
When you try to put in like the term micro, and then it leads you to option that lets you download it.
Oh,
Yeah.
Okay, so for now, it's good to like explore these editors and start with Nano because it would just provide you a more. With Micro, it provides you all the Windows key bindings, but then when you would open Nano, you would see it like how a normal text editor works. It's a little weird, but once you get good at it, you write like very fast on it. Like once you get good at Vim or any one of these, then Vim is the best, but like you can still use the other ones. So we start with Nano.
Not biased.
No, not biased at all.
okay, so piping, you wanna talk about this?
Yeah, sure. So basically, we saw this once earlier, and so he did like ls-lah with grep. But basically what piping is it lets you take the output of one command. So when you ran ls, it shows a list of files that's in a directory, right? So basically what a piping can do is you can take output from one thing, let's say ls, so you list the contents in the directory, and you can use it with another command. So we took the output of ls and we used grep, which goes and basically finds a pattern in whatever it is. So we basically said, I want you to find a pattern in whatever ls outputted. So we can see, I basically ran a command that says ls-lah, and you can see it's outputted everything, right? So we see like bash history, bash rc, but then on the bottom, I put the pipe. So it took the output of what's basically up here. And then I used grep. So I said, okay, take all the output of all of this right here and only look for something that's called snap. And you can see it only listed one thing right there. So that's what piping does. And you can use it with basically any command. And you can also even pipe more. So if we want to do like ls-lah, pipe grep snap, pipe grep something else, or pipe anything, you can do multiple pipes and get like really crazy with that. Yeah.
The way that, just to add a little thing over here with pipes, it's like what it literally means. Like it just takes the output from the first command and then just gives it as input to the other one. So you saw like grep just looks into the input and then finds a specific text pattern. So it just takes the output, gives it to the other program as input. So you can have as many chains as you want, as Bryce was mentioning.
Yeah.
Oh.
Okay, yeah, so then there's basically operators too. So there's like two main operators that you use in Linux. There's like the double ampersand and then the double pipe. So basically the double ampersand is an operator, and basically what it is that you can use, it basically is it'll execute a command given that the previous one was successful. So in Linux, there's actually a binary called true. There's also one called false. And all it does is that if it's successful, it'll do something else. So basically what I did right here is to basically, the definition of this is if the first command is successful, it'll run the second one. So we can see right here, I put true and I put the double ampersand and did ls-lah. So it was like, okay, the first command executed properly because it's just true. And then it'll go and execute the first one. So we can see it outputted ls. But the second one I put false and ls-lah and it didn't do anything. That's because the first command didn't succeed, so it won't do the second one. That's all that is. And then operator, the second one, if you can, yeah, the second one, the double pipe, is basically the exact opposite. So basically the command will only run if the first one fails. So we can see that on the top I put true and ls-lah, it didn't put anything compared to the first one where it did. This one I put false, so it fails, and then I put ls-lah, and then it did that. Well, I'm wondering like, why would I ever use this? Let's say like you're running multiple commands and one of them like fails and you want like a fail safe, something else to happen with it. You can use something like this where, okay, if it fails, do another command and another command or whatever, or if something succeeds, do another command as well, something like that.
Yeah, sometimes like you might get confused if you're like a programmer, you might think it's the OR operator, but it's not. So yeah, don't get those too confused.
Yeah. Okay, yeah. So one other thing too that's really useful is there's basically things called like input output redirection. I don't talk about input because like it's rarely used. I don't really use that much, but output redirection is extremely useful. And basically what it does is that you can take the output of a command and throw it somewhere else. Essentially, it's almost like pipe, but you're just throwing it somewhere else. And usually you put it into like a file or something. So let's say that I run ls-lah. You'd see something like this, right? When you run ls-lah, you see something where you can see all the files, you can see all this stuff on the side. But basically what I did is when I ran this, I put it into a file called file.txt. And then when I use the binary called cat basically goes and outputs whatever is in the file. So I basically told this thing, okay, whatever ls outputs, I wanted to stick it into a file. And then I went and outputted whatever was in the file, which was the output of ls. That's what this right arrow does, is that it'll go and just stick it in a file. But the double one will actually go and append to a file. So what I did is that on the second one, I put IFCCB to this file right here. And then you can see on the bottom, it says IFCCB, basically appended it to it. So if you want to basically clear out everything, like let's say that you had a file and you wanted to get rid of everything, you'd use the right arrow. If you want to append and add on to it, use the double arrow.
What if the file doesn't exist? We'll make a new one?
Yep,
Yeah, it'll automatically
Yeah.
make a new one.
good question.
Okay, so users and groups. So you saw that you know what users are, right? Because you guys, everyone has like a home directory and you guys made a user, right? So your user is like whatever you named it. For me, my name is Sohi and I made my user name Sohi, but you also have groups. So let's just talk about users first. So at a like very basic definition, users are a system entity that can perform actions. All users have a unique username and numerical user ID, also known as UID. These can be used to identify the user. So actions can be identified to a user based on logins. So if you log in as someone, then you will be logged at your actions will be logged as this person. A special note, we also have this user called root, and this is a very special user because this user is basically like administrator on Windows. You know, when you have like, it's like maybe you want to run a like video game, right? It's like, or you want to run some program. It's like, oh, do you give permission to run as administrator? And you just press yes, because I know most of you guys do, or even I do sometimes, but you just press yes, right? So you're running as administrator, which is basically like the highest level of power or complete control. So yeah, and if you're this user, you can basically do anything you want.
So just a thing to add over here, like with users, what you have is now you, like as we were mentioning that on Linux and Unix systems, everything is a file. So that files are actually owned by users and groups. So let's say if you have a file that you want only yourself to access and nobody else can access it in the directory, that's where users are helpful. And for groups, let's say you want to have a file that is only accessible to the developers and not the engineers, or maybe you have like some different groups that you have made of people. So you would see in our FCCSCI system, you cannot access stuff of any other user. Like if you would try to go cd ... and try to go into my directory and try to look at files over there, it wouldn't even let you enter the directory. So that's where users and groups are helpful. But for faculty, Clifton or any other professor, they can actually go into anyone's directory. So that's where users and groups are helpful. There's a group that allows them to access the faculty to access every student. But for every student's user, you are not allowed to go out of your own directory. So that's for groups. And for as Tori was mentioning, users have a unique user ID that's referred to as UID. For groups, they also have GIDs, which is group ID, which separates a group from another group for the Linux system. So here you would see, yeah, go ahead.
How can you access another students?
That's not possible.
Have you done it
You cannot
at all?
at all.
Yes.
Until and unless you find a vulnerability in the Linux system and then you try to look into it. But usually it's there, so students don't do it. So there is a rule that doesn't let you do it, but
But if already is like a faculty laptop,
that's like more on the OSN side where you follow the faculty, look into their laptop and see wherever they leave their laptop, and then maybe you get your hands on it. But even then you wouldn't know their password, so.
Yeah, internet penetration testing is ethical hacking.
Yeah,
Yeah.
exactly. So we follow the ethics or the system guidelines. So for each user, like if you would look at,
But if you find this password, can you log in as them as on your laptop?
Okay,
ethically,
technically speaking, like you can, but you have to know their password.
so from my own laptop, if I can find out a faculty's password.
Yeah, like, it doesn't matter like what
yes,
laptop.
but one thing, network activity is logged. So don't do anything that will lead you in trouble. They can actually look at the IP that you visited the system with and then find you.
So use another laptop.
Don't do ethic. So, yes, so for each user, you would see the username. And then I'm not sure what the X is for, but it talks about the user ID, which is 0 in case of root and 0 as the group ID. And then the home directory for root is /root, it's not in /home/root. So when you would like keep something for the root directory, it's usually in /root. And the default shell. So for most of you guys, it would be DSH when you would try to look into your password file, but we'll be covering that in the future. But this is what groups and users are used for.
Yeah, so what like Missy talked about mostly was like permissions, and we'll be talking about that like a little more in depth. But yeah, users and groups can have certain permissions that are allocated to them, whether it be the user or the group.
Yeah, and one other thing too is that for the UID, you might be wondering like how are the numbers generated? So for the most part, like 0 is always allocated to root, but for most Linux distributions like Kali and other things like that, your own actual user, something that's like not made on the system itself, because a lot of like services and stuff like that will make accounts for itself. Basically, anything that's like an actual user, so an actual person, will start from 1,000 and go up. So if I made an account for myself, Bryce, it'd be UID 1,000. If I made one for Sohi, it'd be 1,001 and keep going up from there. Anything that's under 1,000, you can generally consider it to be like something a part of the system and just don't touch it. Yeah.
Okay, so continuing on for users and groups. So there are some important files that you should know about when you're learning about users and groups. So the first file that we have is etsy password. So you can actually look at it on your systems if you want. You can do cat etsy password, which is printing out the etsy password file. But this file basically contains all users. It tells you if that's what the X is, if a user has an encrypted password, and it usually does. It has the user ID, which Bryce mentioned. The first user starts at 1,000, and it also tells you their group ID, their user home directory, and their default login shell. So just another little note. So for your group ID, you see that it's also 1,000, right? So you might be thinking like, why does a user have like another group ID? So the reason why this happens is because individual users also have like their own like personal group that they belong to, and they only themselves really belong to for the most part. So they literally have like their own user, but they also have their own group. So yeah, and you also see their user home directory, which for this person is /home/their username, and their default login shell is CSH. We also have, also just to mention, so etsy password is really useful because what if you get onto the system, right? You get initial access. Well, what if you want to do privilege escalation, right? You want to go up the ladder and get more power, right? Essentially. So what you can do is you can look at what users exist and you can try jumping around to their user. And so now you know more information about what's on the system. So now there's etsy shadow. So usually you'll be unable to access this file unless you have root permission. If you want to see it on your Kali instances, you can do it with the sudo command. You can do sudo cat etsy shadow. We'll talk about sudo as well, but sudo is basically running the command as administrator. So it's basically like when you click the yes tick box or yes button when it's asking you if you can run this program as administrator on Windows. But basically this file contains hash encrypted passwords for users and other password related information. So for example, for the root user, we have the user root and then it's a long hash. Basically this isn't really reversible because it's hash encrypted, and it's probably also salted, which is another like layer of protection for a hash. But basically for most hashes, they aren't like reversible. You can maybe like crack them based on like common password lists. If a user has a really vulnerable password that's like common, you can run like programs against it and see if the hashes match, because if you run the same hash against the password, you'll have the same outcome unless you salt it. But yeah.
This is how your Linux actually authenticates you. So most of you forgot your password, and what was happening was whenever you enter the password and press enter again, it tries to make it go through the hashing process. It's like a one-way process. You can't really go back, like it's supposed to be done in a mathematical way. But from a very high level view, it's just that it's a one-way process where you give it an input, it encrypts it and gives you an output. You cannot go back. So whenever you enter your password, it does that while you click the login button. And if that thing doesn't meet this hash, it doesn't allow you to log in. So it's an important file. You shouldn't be playing around with this, but it is where the passwords are kept for in encrypted format for your users. Yes.
I typed the shadow one and it told me access information denied.
See, even the Kali doesn't want you to access that file. So you use sudo run as administrator. Sudo.
Yeah, so you just preface it with sudo. So sudo cat etc shadow.
So whenever it gives you a permission issue, you can use sudo to remove it. But you should always be careful before using sudo. Maybe you would do something that will format the whole drive.
How do I
So-
do
Oh,
SUDO.
SUDO, sorry, yeah.
Oh,
Yes, Tony.
No, it's been more like just issues that we have.
Oh, okay, I'll.
Oh.
yeah, go.
Okay. Okay, so lastly, we have ETI group. So this file basically contains all the groups, like all the group names. If a group has encrypted passwords or not, usually groups don't have encrypted passwords, but this X signals that it does. And then it has the group ID, which is 24 in this case, and the list of users within this group. So we see that it has 3 users within this CD-ROM group, which is Vivek, student 13, and Raj. So that's what ETI group is. And this is also like as similarly useful as ETI password because you're aware of what groups exist and what users belong to a certain group. And if the users belong to a certain group, it'll have the same permissions as this group, right? So then you might have more access depending on what user you are and what groups you belong in.
All right, this is going to be like not super long, but it's probably extremely important to know. Not probably, it is. So basically, we mentioned that basically every files on Linux, that's all it is. Everything's a file. So everything on Linux has permissions to it. And basically, there's 3 permissions to it. And if when you did like ls-lah, you saw like a bunch of like this rwx whatever stuff that actually stand for something. So the R stands for read. So can you read a file? W stands for write. Can I write something into this file? And the X stands for execute. Can I actually like run this file if it's like a Python file or something like that? And so basically, permissions that will determine what actions you can do for a directory or a file. And there's actually 3 categories to it. And basically the 3 categories is the owner, so basically who created the file, the group, so who in a certain group, who can go and like access this file, what permissions do they have? And then the third group is everyone else. So if you're not the owner, the creator, if you're not in a group or any of that, who else can run this file? Okay, so I already mentioned that the permissions, there's read, write, execute, so RWX. And I already told you that basically R is read permission, so you can view the contents of a file, or yeah, you can view the contents of a file. W, can you write to it? And then X, can you execute it? Also, something to note too, that's really weird, is that for directories, you actually need to give it execute to like even go into it. It's kind of weird. So if you see a directory with no like X on it, you won't be able to go into it, which is weird. But yeah, basically, if you try to do anything like read, write, execute, and you don't have the permission to it, you'll just get access denied for the action. And I'll show you a little bit more what that exactly looks like right here. So I mentioned that it's represented by 3 characters, so RWX, and there's 3 sections to it. So when you see it right here, kind of how it does on the right, I kind of color coded it for you guys to make it easier because it's like sectioned off by 3 times. So the red one is the owner of the file. So who created the file? And you can see that they have RWX, which means they can read, they can write, and they can execute to the file. The blue one is the group. So anyone in a group can go and read and execute the file. And then the green one is everyone else. So everyone else, if you're not an owner, you didn't create the file, you're not in the group, and basically if you're not in any of these 2, anyone else can read and execute. You're probably wondering, well, how do I know who's the owner and who is in the group? So right here, the left-hand side is the owner of it. So I know it's all root, so it's not really helpful. But the left-hand side is the creator of the file. So root made this file, and the right-hand side is the group. So both the user and the group are both root. But commonly, when you have like your actual own like user, it won't be root, it'll be something else. So you can identify who's a user, who's the group right there. So you can see it like right here, what this is saying, like this snap directory, you can see it's like a directory with this D. It's saying that this root, the owner of the file can read, write, and execute. And then the little dash is basically say that there's no permission. So basically someone in the root group, so the actual owner of the file can do it, but if someone else was in the root group, but not the actual user, they couldn't read, write, or execute, and anyone else could read or execute. So basically, only the owner has read, write, and execute to that directory. No one else can touch it. We don't have questions on that. Make sense? Cool. All right. So anyone probably wondering, well, how do I even set these permissions for things? And that's where this binary in /bin called chmod or change, like you can like modify the binary is it comes into play. So basically chmod will go and modify whatever the permissions are for a certain file or directory or whatever it be. And it's a little weird. It's not like super intuitive. You think like, oh, just type like chmod read, write, execute. No, it's like it's not like that. It's really weird. So the main thing you should look at is the little picture on the right. So the way that Linux does it is that it actually like does like a summation almost of these permissions. So basically, the X stands for execute, right? And basically, if you have one stands for execute. If you have two stands for write. I'm going to jump right here to four stands for read. Basically, what you can do is you can add them up together to go and say what permission you want. So basically 0 means nothing, but I mentioned that 1 is execute and 2 is write. So if you do 1 plus 2 is 3, they give it read, not read, they give it execute and write. So now it's 3. If you're thinking, okay, execute was 1, write is 2, and read is 4, what's 4 plus 2 plus 1? 7. 7 gives it read, write, execute. What if I just want to give it read and execute? Read is 4, X is 1, 4 plus 1 is 5, read and execute. And basically what you can do is, we mentioned it's like categorized to 3 different things. It's the owner, the group, and everyone else. So basically do that 3 times. So the first one will be like, okay, what do you want the owner to have? So I want the owner for this one, 7. What's 7? You're giving it everything, right? So the owner will get everything. Read, write, execute. 5 is read and execute. So now you can see read, not write, execute. And then I want to give it 0, nothing. So everyone else, they have nothing. Make sense? Cool. Also, I don't even know the numbers by heart. I literally just look it up all the time. So yeah.
I think for the numbers, it's just like in binary, it's 1, 2, 4. So like 2 to the power of 0 is 1, right? So that's the most right hand value. 2 to the power of 1 is 2. So you have 2 for the second value, and then the furthest to the one to the left is 4 because 2 to the power of 2 is 4. So that's
that
how
makes sense. I didn't know.
that's how I know it. But yeah.
Oh yeah, and then one last thing, if you go back a slide. So you're probably wondering, what the hell is this thing right here? Because we didn't talk about read, write, execute, blah, 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 blah. So this part right here is actually what denotes what are you actually even looking at. So if we go back to that one, basically there's like 6 or 7 of them that represent like the first bit of this thing. But the 3 you probably need to know the most is the dash is just a file. If you see D, that stands for directory, so a folder. And then L stands for symbolic link or symlink. It kind of sounds kind of scary, but basically all it is like a shortcut to something. So if you had a file called like file and you wanted to go and get a shortcut to something else, the L symbolic link is basically the pointer or like a shortcut to something else. That's all it is. So those 3 is basically what you'll see for the most part. Okay. So there is a little like some oddballs, and it's really useful for people who are into ethical hacking because basically I'll be mentioning 2 things, SUID and GUID. So SUID just stands for set user ID. And if you read the top, basically what it is that it'll get rid of, so remember, we talked about read, write, execute, write, RWS, RWS. Now this is random S that's there. Basically what that does is it says whoever is the owner of this file. So let's say it's like root, right? So the highest, like the most privileged person. You're saying that whatever this file is, whenever someone runs a file, it will go and use the permissions of whoever owns it. So let's say that I make a file, right? And I call it like sensitive data.py, and it's like a Python file that executes sensitive data. And I was like, oh, I'm going to stick this SUID here and have it be the S right there. Basically, anyone who has access to that file now can run it, and it'll be as if I am running it. So anyone can run it, and it's like really, really like powerful. Because let's say that root had that. Root puts this S in front of execution. Now, basically, anyone who runs that file will be running it as the highest permissions on Linux. So that's really important. If you find some file that has that, you can run it as root or whoever is the owner of the file. And then GUID, so GUID, basically group user, like group user ID. It's not as powerful as SUID, but basically GUID is actually just useful for people who want to go and like have permissions where, let's say like you have a directory and you want to basically make it so that like the ownership of the directory, like it's whenever you create new files or subdirectories, you want the permissions to kind of carry on down with it so that someone who's like new to a company is like, oh, I want to access this file. Oh, wait, I can't. GUIDs are good for that because basically it'll recursively go down, like make you inherit the group's ownership, basically. Okay, yeah, so that was it for permissions. I don't have any questions because they're pretty important.
So like with SUI, oh, you go ahead.
Well, it's on the last slide.
Oh, I can go back.
What is the first set of numbers up to 2 R's and then like RWXR?
So RWX, so remember how I said like they're kind of like set, like they're in like pairs of 3.
Yeah.
So
Oh,
yeah, so the RWX is the owner, and then remember the second one's the group.
Yeah.
So you're saying that anyone can execute. I mentioned that directories you can execute.
Yeah.
So you're saying that anyone with this group can go and execute something, and it'll kind of carry down on with it.
Okay. That's right.
Yeah, the first one is not part of part of any section necessarily.
Yeah,
That's why probably I got a little confused. But
yeah. I should have mentioned the S on this side. Yeah. Any other questions? Okay. All right, cool. So you might have heard this here mentioned earlier, like this like app or something like that. Basically, for Linux distributions, there's these things called package managers. And the way I like to think of it, and this year like talk about it perfectly, is like when you're on Windows, you have like the Microsoft Store that the download apps, or you have like the App Store on Mac and your iPhone and stuff like that. Basically, package managers is basically like a package. It's like a collection of files that you can go, and basically these collection of files will go and be software that you use. And so package manager is just managing a bunch of packages, which is the packages of a bunch of files that will be software that you use. So basically, Linux will use this package manager, and there's a couple of them. There's like Pacman, Yum, Apps, DNF, RPM. These are all the different ones that you got in different distributions. So we mentioned there's like Kali, which is what you're all using right now. There's like Ubuntu, Debian, there's like CentOS, there's like Red Hat Linux. There's a ton of Linux distributions, and they might have pre-installed different package managers, but they all do the same thing. All they do is they manage software they have, and it's just a big, gigantic list of like packages and like software you can download. And all you can do is like, if you were to do it on Kali right now, if you type apt and then like install, blah, 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 whatever you want to do, it'll go and install it for you. That's all package managers are. Any questions on that? Cool.
okay. Okay, so services. So services are either programs or daemons. Basically, daemons are like non-interactive. They're a little different from like service programs, but basically that run in the background. But what services are they're like little programs that provide specific functionality. For example, they can do like database management. For example, like MySQL is a service for database management. There's web hosting. Some prominent ones are Nginx and Apache. And then we also have like network services like FTP or even SSH. That's like a service that runs on the Fullerton College computer science server, in which you can interact with that service and connect to. So services like logically can be a little confusing, but that's basically what they are. They're like that programs that provide a specific function. So we can also manage services with service configurations. Configurations for services often exist in /etc, like we mentioned a while back, but a lot of configurations will exist here. For example, for Apache 2, which is a web server, you can make configurations in apache2.com, and there are a lot of other files within the Apache 2 directory that you can configure, but that's one example. Configurations basically just change the behavior of a service, but they should be modified cautiously because you're basically making changes to the service, and you could be changing something that's critical. But common services are like DNS servers, firewall services, HTTP servers, and database servers, like I said above. But yeah, That's what services are. And so what you're gonna do a lot, or yeah, I guess a lot. And you're also gonna have to be like familiar with it is service management. So you're probably mostly gonna see system D, which the command for managing system D is system CTL. Kind of weird, yeah, it's called two different things. But that's how it works. So you're gonna use the command that the command you're gonna be issuing is system CTL. And these are just like a list of like the most basic things you can do with system CTL. But it's basically the system CTL or system D is like a system manager or service manager, and it'll manage all your services for you. So like I said, SSH is running on the Fullerton College server, right? So they're probably running it through system CTL, and they just probably did system CTL start SSH and probably enable as well, because start is when you're starting it like currently, but enable is when you start it at boot. So right when you turn on the computer, it'll start immediately. And sometimes that can be useful because maybe that's what you want. So what I did here in this picture, or what it's doing is it's just showing the status of the service SSH_d.service. Sometimes they're called a little different. They might have like .service appended to it, but that's what it is. It's SSH, and it just shows you that it's active and running. A lot of times it might be down and you might have to do some debugging, and that's when you can look at the status page, and you can make configurations in the /etc and then whatever configuration file there is, but that's basically it. Yeah.
I think system CTL is like one of the most important commands that you would ever work on Linux, because when you would like check for system CTL list, it would show you like all the background processes that are running. And when you would see them, you would see, oh, there are a lot, even though you haven't installed anything yet. So there is a lot of services. Let's say you get into a web server and now you want to, and the web server is not working. So now you would try to like see if it's managed by system CTL and try to see if it's Apache, Nginx, and you get the stats from here. So the most important tool is system CTL status, which allows you to like get more information about that service. But these are some of the handy operations that you can do with system CTL, and there's like way more if you would do man system CTL and see all the other commands that are available.
Yeah, and sometimes like if like a service is down for some reason, it'll say like down, and it'll like give you like errors, and you can like utilize those errors to maybe like sometimes fix the service. So it's pretty useful. Okay, so that's it for like the lecture. I know it's really long, but it's really important to get all that through. So we'll have like a Linux lab, and basically you're going to be going to this site right here, overthewire.org/wargame/bandit. And if you go to that website, there's like a bunch of different levels, and I know there's like a lot of levels, but I promise you, if you complete all these levels, you'll be like pretty comfortable with Linux at a basic level. So I just put how to get started on level 0. I was talking about SSH, but this is how you would do it to connect to their server. But basically what you're doing, you're issuing the SSH command, you're specifying the port, so you have the -p argument or the option. You're providing the data, which is 2220, and the syntax for SSHing, you're going to do your username, which is bandit0, and you have the @delimiter, and then you have either the server name or the IP. And in this case, you can just put the domain name, which is bandit.labs.overthewire.org. So you can just literally copy and paste this into your computer, and if it asks you for a password, which it will, this is the password. And you might see this often, just to let you know, but when you're like working with usernames and passwords, the syntax will probably be username on the left side, colon, and then password. So that's why I just put it up there for you guys to get comfortable with it. And the last thing is to probably get to keep track of your flags on a document or wherever, because submitting your flags will be part of the homework. So depending on how many you submit, that'll just like be most of your score. So yeah. If you guys need help getting started, we can go around.
Now for the previous homework.
Oh, you want to talk about the previous homework?
Oh, yeah. So basically there's people kind of some issues of right for the homework. So we're extending it to midnight on this Friday to complete the homework. Also, if you have any questions, please don't feel afraid to reach out. We're here to help you. Yeah. Also, I want to mention one thing about the command. If you're wondering what like the 220 is or what domain names or IP addresses are, I know so he mentioned that. we'll talk about that next lecture because it's all networking based stuff. So we'll talk about what that is later.